day, you'd have graduated away from that other math into understanding algebra. It doesn't have to scare you. It's just a big fancy word for saying math. And if you're this far already, that means you understand math and you can do this. You're ready for this. So let's do it. Algebraic terms. The idea of terms is not a new concept. We often talk about terms in regular math in lots of different ways. We talk about the terms, reduce to lowest terms, right? You've heard that phrase many, many times throughout your math career. But now as we start looking and thinking algebraically, terms has to deal with whole numbers and integers, and we can talk about variables. Each of those could be considered a term. And because each of those is considered a term, we can start to look at how terms can be joined together and form different kinds of polynomials. That's the word I forgot to put in the video, polynomials. Polynomials are groups of terms, and we want to take a look at some examples of polynomials. Now, depending on the number of terms that end up in a number sentence or an algebraic sentence, we want to be able to identify them. So we have what are first of all known as monomials, right? Which means there is one term. So this by itself is a monomial. 2 times x, or 2x is how we would say that. Right? Just like -3 is a monomial. Monomial? We'll work on pronunciation as we go through this. Right? And also 4y squared is also a monomial. It's one term that's alone by itself in an algebraic sense. All right? And so we have that idea. Now, from here we go to binomials and trinomials. And so we can see kind of what's happening is I'm taking one of these terms from up here and I'm combining it by adding a order of operation, like plus or minus, and can even get into multiplication and division, though for the most part we stick with plus and minuses when dealing with polynomials. As we look at this then, we now see the idea that we took this monomial and we're adding it to this monomial, and in the essence we're getting what's known as a binomial. Together they create a binomial. Just like this over here also becomes a binomial. I have one term minus another term, and so I have a monomial. And of course then we get to trinomial, and of course you have 3 terms now, 1, 2, and 3, right? And technically we could say that this, not that, this plus sign would go with that 2x, right? So identifying them, that's step 1. That's what we want to be able to do. We want to be able to break down a number sentence. So let's take a look at this trinomial. So this is a trinomial, and as we break down this trinomial, we want to understand the different pieces that are available on each of the terms. So we have 3 terms. We have 4y squared, right? 4y squared. Right? We have an x, right? And we have a -3. -3. So those are the 3 terms that we see in this trinomial. From this term, we can kind of break it down to see which parts of that term are numbers and which parts of that term are variables. So I look at this, 4y squared, and I have a 4, which is my number, and I have a variable, a y, which is squared, so y times y. Right? That's why that 2 stays with the y, because it's technically y times y. Okay? Here I look at my letter x. And the first thing we see is a number 1, the coefficient of 1. And you might say, I don't see a number 1 right there. And that's because 1s are understood. Right? Whether they're negative 1s or 1s, we always understand that there's always a number in front of a variable. Always a number in front of a variable. And that number, of course, is 1. Because 1 times x is going to, of course, be x. So more often than not, we just don't include that when we're writing the expression. But we do want to know that it's there. So we have 1 for our number, and x is our variable. And finally, we get to our -3. Negative 3, of course, is our number, but there is no variable. There's none. It's not there, and that's okay. It's okay to have a number by itself. Sometimes it's called a constant. There's a number of different terms that will start to appear in our math book that have to deal with these different concepts. All right, take a deep breath now. Let it all soak in. All right. Okay, if you got a question, if it's not quite sinking in, write that question down as we move in. Okay. From here we want to talk about how do we combine like terms, right? Combine like terms. And by combining like terms, we want to find things that are similar. So first we want to identify the terms. Our first term is 3x. Our second term is a positive 2. And our last term is a negative 1. As we think about those terms, which terms could we combine together? When I say that they're alike, that means that they would match in one of these columns. They're either going to be a number with a variable that has the same power, right? Number with a variable, same power, or it's just going to be a number by itself. So looking at this then, we would say, okay, I got a 3x, and nothing else looks like a 3x. There is no more x's, so 3x is actually going to stay by itself. But what I can say is I have a positive 2 and a negative 1, and those are both just numbers. So let's combine those together. Let's simplify it. So 2, positive 2 plus a negative 1 equals 1. Right? That's the same as saying 2 minus 1. And so in the end, I'm going to come away with a positive 1. And so I've simplified this expression to now equal 3x plus 1. Let's get a little more complex. Right? Here we have this algebraic expression. We have 4x plus 5 plus 2x minus 3. First of all, we want to identify our terms. First term is a positive 4x. Second term is a plus 5. Third term is a plus 2x. And our fourth term is a negative 3. So now let's group the things together that go together. All right. As we start to group things together, we want to combine things that are similar. Right? That's why we call them alike. So I take my 4x, and is there anything that looks similar or exactly like it, right? The number doesn't have to be the same, but the variable has to have the same power. And so I can say, okay, this is an x and this is an x. They both have the same power. And so I can take a 4x and a 2x, and I'm going to be able to add them together. By adding them together, this is what we're going to do. Since this literally says 4 times x and 2 times x, what math shows us is that our x is actually going to stay the same. That number has not changed. It's the same. But what has changed is we can take this 4 and we can add it to our 2 and now get an answer of 6x. Let me show you how this works in a numerical sense. If I have 3 times 2, that's the same as taking 2 times 2, 2 plus 2 plus 2, right? 3 2's. If I have 4 times 2, that'd be the same as 2 plus 2 plus 2 plus 2, right? Because multiplication is repeated addition. Now, if I count this up, 1, 2, 3, 4, 5, 6, 7, wouldn't it just be the same to say 7 times 2? If I were adding these two together, it would. And so in the end, I add these two numbers together, and this stays the same. And so this helps us understand why we can take a 4x and a 2x and add them together. Because it's really just repeated addition of these x's. You're really saying I have 4 x's, x plus x plus x plus x. And you're adding it to an x plus an x for a total of 1, 2, 3, 4, 5, 6 x's. All right, so we've simplified that. Now we want to group our numbers together that aren't attached to variables. So we have our 5, positive 5, and we have plus a negative 3. Right? We always add because we're thinking algebraically. Right? 5 plus a negative 3 in the end is going to give us an answer of positive 2. And so in the end, our simplified expression is 6x plus 2. And I'll rewrite that. 6x plus 2. It's your turn now. Simplify this by combining like terms. Come ready with your questions. We'll see you in class.